Okay, in this video we're going to look at factorising. Factorising means just splitting up, okay, splitting up into different things. I suppose sometimes factorising can help you make something a little bit simpler. Alright? There's 4 ways that we learn how to factorise. We factorise using common factors, by grouping, by difference of 2 squares, and factorising quadratics. Alright? I suppose there's different things to look out for, and I'll go through them on the way. The common factors method, what I would suggest with the common factors method is, if none of these methods are possible, then use the common factors method. Okay, that's the way I usually look at it. Okay, so I'm going to take you through the common factors method first. Common factors method is what it says it is that you take out a common factor. So you take out something that goes into both. So if we look at example 1, we have 6x and 18y. Now what can I take out of both of them? Whatever I can take out of both of them, I'm going to put it outside the bracket. Well, 6 will divide into 6x, and 6 will also divide into 18y. So I'm going to take out 6, that's common to both. Now what do I have to do to multiply, to 6 to get back to 6x? I multiply it by x. Plus, what do I have to do to 6 to get back to 18y? I multiply it by 3y. Okay, so that's that done. Very easy. And I suppose, just to look, if we multiply this by this and this by this, we get back to this again. Okay, so that's how we know we're right. Right, let's try it over here. What's common to both of these? I know the 3 is common. B is also common, so I'm going to take out 3b. What do I have to multiply 3b to get back to 3ab? Multiplied by a. Plus, what do I have to multiply 3b to get to 3bc? C. And again, if I multiply this by this and this by this, I will get back to this. Right, let's look at this. What's common to both? Well, there's definitely a 5 common to both. There's a p common to both, and there's a q common to both. So what do I have to multiply 5pq to get to 10p squared q? Definitely have to multiply it by 2, and I definitely have to multiply it by another p, because we have p squared. And what do I have to multiply 5pq by to get to 5pq squared? If I multiply it by another q, I get the q squared. Okay, so that's our common factors done. Grouping. How you'll know that you should choose grouping is, it's going to look like this. It's going to have 4 different sections split up. Once you see something like that, there's a very, very good possibility. In fact, for the junior cert and leaving cert, it's a definite. Okay, if you see 4 small groups, then you know it's grouping method to be used. This sometimes is a bit of trial and error. Okay, we need to pick 2 pairs, and then group them together and factorize it. So kind of like this one, we see what's common in both and we factorize it out. But this, we're going to take 2 pairs and factorize it out. So again, I'm just going to chance my arm and I'm going to take these 2. Again, we'll see will it work. It mightn't. What's common to both of these? Well, there's a b common to both of these. And I have to multiply b by a to get to ab. And I have to multiply b by 5 to get to 5b. And now we do the same for here. So what's common to both? There is 3 common to both. And I have to multiply 3 by a to get to 3a. And I have to multiply 3 by 5 to get to 5. Now how do I know if I'm right? And how do I know if I've done it the right way? Well, if I've done it the right way, then what's in the brackets is going to be the same. If I get to this stage and both brackets are the same, I can take what's outside the bracket, the b plus the 3, and put it in one bracket, and I can put the a plus 5 in the other. Okay, and that's done. And the magic is, if I multiply these 2 brackets, this by this, this by this, this by this, and this by this, I will get back to that. Okay, let's go for the second one. So again, I'll take these two and see can I factorize it out. So I have an a, an n, and minus 5. Okay, a by n is an, a by minus 5 is 5a. And I'll take these and factorize it out. Again, this might not be right, but we'll have a go. So what can I take out of here? Well, b. I'll try plus b. So we have an n, b by n is bn, and b by minus 5. Okay, so that worked. Why don't I know it worked? Because I'm the same in both brackets. Okay, let's try it a different way. See would it work if I chose different to. Well, actually, we finish this first. So we have outside the bracket we have a plus b. Inside the bracket we have n minus 5. There we go. Okay, done. Let's see if I can work it a different way. Sometimes there's two ways of working it. Sometimes we have to play around with it to try to get the right pair. Okay, this time I'm going to take this pair and factorize it out. And then this pair. Let's see would it work. We'll take the two 5's first. Right, I'm going to factorize out minus 5. And I'll have a plus b in the bracket. And then the next one I'll factorize out n. Okay, so I factorize out n from here. So I have plus n, and I have a plus b in bracket. Okay, this actually also works. Okay, because I have the same in both brackets. So I have minus 5 plus n and a plus b. Okay, if I multiplied this all out, I would get back to here. Some of these questions though, you know, if I factorize, let's say I took these two and then I took those two and factorized it out, and I saw that this and this was not the same, well then I would have to go for another pair and see could I factorize it out in such a way that whatever's in these brackets are the same. Okay, it just so happened in this one that whatever way I did, whatever pair I chose, it worked. Okay, next up, the difference of two squares. So I'm just going to write out these square numbers for us. 1, 4, 9, 16, 25, 36, 49, etc. Okay, so these are special enough numbers because 1 squared is 1, 2 squared is 2, 3 squared is 3, 4 squared is 4, 16, sorry, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared, 7 squared, and so on. You get the drift. Okay. So this is the difference. Difference means minus. Okay, we should know that. And two squares, well, these are square numbers. So by just reading what's here, we're looking for a minus and two square numbers. If I have a minus and two square numbers, then I can do this form of factorization. So if we look here, we do have a minus. Now have we square numbers? We have 9s, we have 4s. Brilliant. I have two square numbers and I have a minus. I have the difference between the two square numbers. If that's the case, I can do this. Two brackets, 1 plus, 1 minus. Get the square of this, 3x. Put it in both. The square of this, 2. Okay, that's it. Done. To show we're right, or to prove we're right, if I multiply this by this, this by this, this by this, this by this, do you know what I get back to? Yeah, you've got it. That. Right, let's go another one. Do I have a minus? Yes. Do I have two square numbers? 25, 81. Yes, I do. So, 2 brackets. 5a 9b plus minus, sorry, what am I doing it for? 5a plus minus. Okay, so the 5, so 5a by 5a is 25a squared plus and a minus, and 81 then is 9b. 9b. Again, if I multiply this by this, and this by this, and this by this, and this by this, I will get back to this. Okay, last one. Right, I have a minus. I have squares all right here. The only problem is the numbers. They're not perfect squares. They're none of these numbers. Look, 12 is not here. 75 is not here either. They're not square numbers. However, a little bit of intuition, and I can use the difference of two squares in this. Watch. First of all, I'm going to use the factorising method. Remember the factorising method? It's back here, the common factors. Right. So to look at this straight off, we would say we can't quite use the difference of two squares methods because these numbers are not square numbers. So, by that logic, I'm going to factorise out stuff. But here's what I'm going to do. I'm going to leave this x squared and I'm going to leave this y squared. I'm not going to factorise out any x's or y's. All I'm going to factorise out is a number that goes into 12 and 75. And I know 3 goes into 12. And if I factorise out 3, well then 3 multiplied by 4x squared is 12x. Minus, and if I factorise out 3 from 75 y squared, I get 25 y squared. Okay, so I've done the factorise out bit. Now, hold on a second. If we look at this bit, there's a nice square number. There's a nice square number, there's a difference. So even though it didn't start out looking like one of these difference of two squares, by actually factorising out the 3, now I do have a sum that I can use the difference of two squares. So again, we keep the 3 out. So it'll be 2x plus minus 5y. And I suppose just to let you know, if I multiply this by this, this by this, this by this, this by this, and multiply my answer by 3, I will get back up to this. Okay, last one, guys. And we've looked at this already. Okay, we've looked at solving quadratic equations, and we've looked at factorising them out. We've looked at using the minus b formula, and we've looked at factorising. I'll just keep going. I'll just do this because this is the fourth way. So if I have a quadratic means if I see an unknown squared, okay, so usually an x squared, but it could be a y squared, or it could be a t squared, or whatever, then I know it's quadratic. It's quadratic, and I want to factorise it out. I will draw two brackets. I will look at my last number, okay, the one without an unknown, and I will look at numbers that multiply to give us that number. So 12 multiplied by 1 gives me 12, 6 multiplied by 2, and 3 multiplied by 4. Okay. I'll also put in my two x's because it's an x squared, so x by x is x squared. Now I ask myself, which one of these three numbers can add or subtract to give me 8? Well, 12 plus 1, 13, 12 minus 1, 11. Definitely not that. 6 minus 2 is 4, 6 plus 2 is 8. That's what I'm looking for. So I'm going to be using the 6 and the 2. They have to multiply to give me plus 12, so the signs have to be the same. They have to add to give me plus 8. So 2 pluses. That's those factorised. And again, if I multiply that by that, that by that, that by that, that by that, I will reverse what I've done and I get back to my original answer. Last one, numbers that multiply to give me 18. 18 multiplied by 1, 9 multiplied by 2, 6 multiplied by 3. X by x is x squared. Numbers that multiply to give me 18 but can add to give me 9. 6 and 3 will give me 9, so it's definitely the 6 and 3 I'm looking for. Now they have to multiply to give me a plus, so the signs here are going to have to be the same. So I use two pluses. Yes, that will add to give me plus 18. However, plus 6 and plus 3 is plus 9, not minus 9. So two pluses won't work. Try two minuses. Minus 6 multiplied by minus 3 is minus 18. Minus 6 and minus 3, minus 9. There we have it factorised. And again, if I multiply out the brackets, I will get back to the original answer. Okay, so that's factorising out. Okay, thanks guys.